Hello, statistics student. This video is for chapter 11.3, chi-square test of independence. We talk about what it is used for in the last video. Chi-square test of independence is to test two categorical variables are dependent or independent of each other. And in general, we say it uses chi-square distribution, and also it's always a right-tail test because large chi-square value corresponds to the alternative hypothesis value that you are surprised. So when the observed and the expected counts are very different, then you say that, oh, they affect each other. So here are the steps. The first step is to write the null hypothesis and alternative hypothesis. The null hypothesis is always that the two variables are independent, that there is no association, they don't affect each other. They should have very low very low chi-square value. The alternative hypothesis would be the opposite, which is the row and column variables are dependent of each other. They're dependent events. There is association. They affect each other. Okay, so this would be when you have a very large chi-square value. So it's a right-tail test. You see that there is no greater than or less than for you to look at. You just have to know for chi-square test of independence is always right-tail test. Second is you would put the table into statis. So if you open up statis, you put your table like each column value. If there's 3 columns, you put 3 columns. If there's 2 columns, you put 2 columns into statis. And then the command that you use to do the analysis of chi-square test of independence is analysis, go all the way to contingency table. And that's it. Okay. So you would put the significance, check all the columns that has the tables and evaluate. Okay. So I don't have anything here, so there's nothing to output. The output would be there's a degree of freedom that they output, a test statistics, which is chi-square, and a p-values. So that's the second step. The third step would be if p-value is less than or equal to alpha, the significance, then reject x0. X0 means X0 is claiming or temporarily assume that they are independent. So if you reject it, that means they are dependent. The row and columns variables are associated. They affect each other. But if p-value is greater than alpha, that means it agree with the fact that they are independent. So we would conclude independence. So step 4 would be conclusion about the claim. If the null hypothesis is rejected, that means there is sufficient evidence that you will use the sufficient evidence statement. If x0 is failed to be rejected, there is not sufficient evidence. Okay, so do you do support or reject based on whether your real claim is in you're claiming dependence or independence? But actually, when you look at the p-value, you already know if they are dependent or independent of each other. Now, the last things you want to check is for chi-square test to be successful. There is a very strict requirement that all the distribution of the proportion has to be normal, and this is guaranteed by saying that the success and failures are at least 5. So we have to check that all expected counts are at least 5. Okay, so usually what I'll do is, how do I do expected count? The expected count is row total times column total over the grand total for that particular cell. And then usually I do not check every single one because I only need to check the smallest one. If the smallest one is at least 5, then everything should be at least 5. Okay, so let's do an example. So someone is trying two treatment to quit smoking, nicotine patch and nicotine gum, and this is a data. So both of them are not very successful. Only just a small amount of people would quit smoking after maybe it's not too long. Maybe it's a month. I don't know. They didn't say anything. So it's very hard to quit smoking. So don't start. Quit smoking. Keep on smoking is 191 out of 59. for gum is 263 out of 57. So it seems like gum has a higher failure rate. Is that right? Because the total number of the nicotine gum seems to be higher. But is it because of just sampling variation that it is, seems to be higher, or actually this is not as good? So we want to see if the result is dependent on the treatment. This is very useful. So when you are collecting the result in terms of not counting anything, but counting the result, whether there's success and failure, we can use chi-square independence to check. Okay, so first is to write the hypothesis, the null hypothesis. Oh, I should say null and alternative hypothesis. Right, you need to write, and most importantly, write the alternative. In statistics, you don't need to select the alternative because there's only one way. Everybody know X0 is independent, HA is our dependence. And you have to record that earlier we say they are independent of the treatment. So you say my claim is in X0. Okay, so that would means in my final conclusion, my claim is waiting to be rejected. Okay, 2. Input a table to stat this. So I have written it down. Where is it? 191, 263. So let's input it. Okay, so get 191, 263, 59, 57. Is that what it is? Yeah. And so we're comparing these two to see if they are dependent on each other. Analysis, contingency table. Our significant is 0.05. We only have 2 data value. And that is our conclusion. Oh, that is our results. Our p-value is our degree of freedom is 1. Our test statistic is 2.9. Our p-value is 0.0886. So we write it down. We write down that degree of freedom is 1. Test data is 2.9. P-value is 0.0886. But 0.0886 is quite low, but it's still greater than 0.05. So we would say, well, the chi-square is big, but it's not as big as the cutoff. So fail to reject 0. Conclude that there is no association because X0 means they're independent. Conclude no association, they are independent. So whatever treatment you get, actually the results are more or less the same. And then what's the final result? So because we don't have a significant sample, so there is no sufficient evidence to, I say, reject. Why? Because my claim is claiming them to be independent, which is X0. So we say no sufficient evidence to reject the claim that the results and success are independent. The result and the treatment, I should say. The result and treatment. So it means if you want to be successful, you don't have to choose any. Just pick one. They're more or less the same. Okay. So the last things we want to do is check the expected count. So the way you check is you have to look at which one is this is the lowest. Oh, so first do the grand total first, right? So the grand total would be adding all of them together. 191 plus 263 plus 59 plus 57. So it's 570. The one with the lowest row total would be, I think, this one, right? 59 plus 57, 116. Out of these two, which has the lower column total? This is the lowest column total. 191 plus 59 is 250. So the lowest expected count would be, I think they should be greater than 5, but just formality, I would have the row total 116 and the column total, the lowest one, and then over the grand total. So 250 times 116 divided by 570, 50.8. 50.9. So this is greater than 5. So the expected count is at least 5. If the least is at least 5, then all the others are at least 5. And I put it here. So is it 61? How come I got 57? Did I put something wrong? Oh well, don't know what that one is. Um, I'll fix this. Oh, maybe the total is wrong because I get 570, but that one is 470. Did I get 470 right? Wrong? 151. Okay, let me just make sure that my grand total plus 263 plus 59 plus 57 is 570. So that one was wrong. So it'll be 50.9. So I'll make this change. So I put 570. It will be 570. So it'll be 50.8. Greater than 5. So that's right. Example 2. So we do another experiment for a treatment of cold, I think it is. So, not a treatment for like preventing cold. So, would you be affected by flu or cold if you take some, you know, Echinacea? This is kind of some kind of herb, but 20%. So, and another treatment would be 60% of the herb, and then there is a placebo that don't take anything. So, see if it would actually help you to prevent cold infection or virus caused by the cold virus or a sickness caused by the cold virus. So anyway, we want to see if the types of treatment affect the results. That one of them is better. Now, if you just look at them, you can see that the placebo has a lot of people get infected. But if you take both of these, they're actually quite successful, right? So is the success rate, these two success rate are pretty much the same, or they're quite good, but it is very extremely better than the placebo, right? So how do we do that? So we would put this table into stat this, right? First of all, write the x0 next one. X0 is independence. The infected outcome is independent of the treatment. And then alternative is they are dependent of the treatment. If you go to placebo, you might not, right? So and then you notice that the claim is actually HA. Your claim is that it depends on the treatments. So we input it to stat this. I think I have it typed up here. Right? Do I have it here? Affected. Yeah, this one. I also do some total. So clean up all this, clear all this, and do a control V. So I have these three columns of data, and I'm going to do analysis, contingency table. We have 3, right? 3 treatment. And so we write this down. The result is 23.18. Degree of freedom is 2. P-value is 0. So the area is so low. Okay, so I write it down. 23.19. Actually, it's 19. Degree of freedom is 2. And p-value is 0. So p-value is 0. Of course, it's less than 0.05. So we reject 0, concluding that they are not independent. They depend on each other. The infected rate is dependent on the types of treatment. So it can actually help you to prevent infection. So let's check the expected count because chi-square test is a very strict test. You have to make sure that all the inputs are actually normal. So let's see. I think this is the total. This is the grand total. So which row has the lowest? Yeah, so this is the total column. This is the total. So this total is 103, this total is 52, this total is 52, this row total is 62. So these two numbers are the smallest, right? So expected count, the least expected count is 52 times, I can't see, is it both 52? And then over the grand total of 207, I have 100%, I'm almost 100% sure that it is greater than 5, but for formality, we just do it. It's 13.1. It's greater than 5. How come I'm also wrong? Oh, this is 62. So it should be 15.6. Right? This is